So let me explain this. It's very simple concept also. It is not that complicated. First, let us understand with the help of a diagram. Okay. And yesterday I told that I'll tell someone, Jyoti or someone told, no, you people told it as preponed you told or postponed you told. I got confused there. Inputs queue gets executed in the postponed region. Okay. I yesterday someone texted, no, who was that? Jyoti, was it you? Jyoti,
No, ma'am.
I think it's Sudha.
Sudha.
Yes, 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 she's absent. What she had told yesterday, preponed she told or postponed she told?
Postpone only she said, ma'am.
Oh, okay, okay, okay. So I thought it as preponed. Okay, so it is correct only. Inputs queue gets executed in the postponed region. Outputs queue gets executed in the observed region. In the event scheduler diagram in your notes, go and update this. Okay, and as I told yesterday, inputs queue 1 nanosecond, outputs queue 0 nanosecond. So these 2 points are very important with respect to your interview. So clocking block. Definitely, they will ask what is an advantage of clocking block, definition of input and outputs queue along with the waveform. Okay, I have given the waveform yesterday. That waveform is 100% question. Okay, and these 2 points, default values they'll not ask. Even if they ask, outputs queue is 0 nanosecond, inputs queue is 1 nanosecond. And with respect to the event scheduler, in the event scheduler diagram I had not kept these two statements. You people have to update in your notebook. Okay, yes. So make a note of this assertion. As I told, I will tell at the end of the syllabus. Okay, because assertion and action block are there na in the event scheduler. That comes at the end of a SV syllabus. Okay, yes. 1 second. Okay. So without just remind me to take the attendance at the end of a session. Okay, yes. Okay. So now first coming to class assignment. Okay, class assignment is very simple. See, you have one class. Okay, class and class, you are having one class and class. Okay, so you just want to assign something, means see, I will create one handle for this. How to create a handle? Suppose the name of this class is p1. Okay, the syntax is p1, and the name of a class is p1, and I will write p. So the p is a handle for this particular class. That's it. Okay, for this p, if you want to create an object, yes, you can create new, which means what? The memory is created. Now this is called as object. This is handle, this is object. Okay, now let me create another handle called a. Okay, so p1 comma a. Now what I'll do, it is just class assignment, which means what? P is already memory is present, correct? No, now what I'll do, p equal to, see, in this way you have to read from right hand side to left hand side. Okay, p equal to a, which means what? Whatever was present in p, that is now again belonging to a, which means what? In the diagram now, if you see, p and a both are pointing to the same memory. Okay, now with the help of p dot, suppose you just imagine here we have address and data. Okay, now if you write p dot address equal to 44, if you write like this, that address variable is going to get updated here. Okay, now using a, if you try to access address, a dot address equal to what you will get? You will get 44 only, because both the pointers are pointing to the same memory. Actually, this is the disadvantage. Okay, so when you do the class assignment, this is the syntax. Okay, when you do the class assignment, both the handles are pointing to the same memory. To avoid this, we are going to shallow copy. We are going to shallow copy. In the shallow copy, what happens? I am using same syntax. How I'll use means, see, p a equal to new of p. I'll write like this. What happens here? The piece already one memory is there na, that particular memory is getting copied into a new memory of a. So a is now having a separate memory, p is now having a separate memory. So whatever changes you make in this memory, it is reflecting only here. Whatever the changes you are making in this particular memory, it is reflecting only here. So two separate memories you will be having in the shallow copy, whereas in the class assignment both the handles are pointing to the same memory. Okay, using handle 1, if you do the change also, using handle 2, if you do the changes also, it is reflecting in both the side. But here, whatever the changes you make using handle A, that is reflecting only in this memory. Whatever the changes you make using handle 2, that is reflected only in this particular memory. For that, only one extra word you have to add, that is new, because my intention is I want to create a new memory to A handle. Okay, so that's what exactly I'm trying to do it in the shallow copy. But in the shallow copy, again you have a disadvantage. What is the disadvantage? Means, suppose if we use nested class. So Yashwant, what is nested class? Yes, Yashwant, what is nested class?
The class which is written in other class is called nested
Very
class.
good, very good, very good. So now in the shallow copy, when I take nested class, what happens is, for the nested class, again the same problem will arise. Both the handles are pointing to the same memory. Okay, what a disadvantage I was having in the class assignment? No, same disadvantage again it will come in the shallow copy. But disclaimer, if I use the nested class only, I will get the disadvantage. In the shallow copy, if I don't use nested class, this is perfect. Okay, in the shallow copy, if I use nested class, again the same disadvantage will come into picture. Okay, now to remove this disadvantage, again I will go for deep copy.
Ma'am,
Uh,
what is the disadvantage? Can you repeat it?
Class assignment, did you understand?
Class assignment, I understand.
Same disadvantage you will get in nested class.
What type of disadvantage?
This only pa. This, what is this? Both the pointer are hand pointing
Both are pointing towards the handle.
same.
Updated the same value.
No, both the handles are pointing to same memory.
Same memories. Yes, same memory.
This is a disadvantage, correct?
Okay,
Huh.
both because of both are pointing towards the same
Same
memory. That
memory,
is
it is
all.
actually disadvantage, because whatever the
Okay.
that same disadvantage you will get in nested class also. Suppose if you use that in the shallow copy code.
Okay.
Okay, now to remove this disadvantage, I'll go to the deep copy. In the deep copy, what happens? Even that nested class disadvantage also will get eradicated. But how means, we are supposed to use a copy method. Copy method. Okay, so this is the theory explanation that you have to give it in the interview. Okay, I repeat again, in the class assignment, what happens? Both the pointers or both the handles are pointing to the same memory. This is a disadvantage. To eradicate this disadvantage, I will go to the shallow copy. In the shallow copy, what happens? One handle is pointing to different memory, another handle is pointing to different memory. The problem is resolved. But once again the problem will arise if I am using nested class in the shallow copy. Okay, next, in the deep copy, what happens? Nested class problem is also resolved. But how? By using the copy method. Copy method has to be used in the nested class. Okay, now this is the theory explanation. Okay, and the syntax also you people are supposed to remember. So here in the class assignment, it's very simple syntax: p1 equal to p2. In the shallow copy, it is like p1 equal to new of p2. Okay, in the deep copy, 2 3 syntaxes are there, whichever you want you can use, but here what I can use is copy of p2. Okay, see, p2 dot copy, anything is fine. Okay, many copy method, it can be utilized in many ways. So these three syntaxes you have to remember. First is you have to explain the differences. Okay, even though the interviewer is asking you the difference between shallow copy and deep copy also, it's your responsibility that you have to explain all of the three. Okay, because you can't explain any two, you should explain completely these three answers also, one by one. Okay, and second point will be your syntax. Okay, syntactically you are supposed to explain this differences. These 2 points you are supposed to tell. That's it. After this, if the interviewer is asking you to write the code part, okay, then you are supposed to write the coding. Okay, so let me now go to code. Let us understand one by one. First, let me take class assignment. Hmm. Okay, so class and class. Inside the class and class, I have written some properties. and I have written one method. Okay, now so what is the property? Data write packet type. For that data write packet type, I have initialized some values in the constructor. Okay, constructor method I have to call. I am supposed to call this as constructor method. I mean to tell the function name itself is new. Correct? No, that is why I am calling it as constructor. That's it. Okay, so in the constructor method I am initializing the values. That's it. And these values I am trying to display. Simple thing. I have declared, I have initialized the values, and I am trying to display that in the another function. Now in the class assignment, what I am trying to do, I have created two handles for the same class. Okay, two handles I have created for the same class. For one handle I have created a memory. Okay, and I'm trying to display the packet one. Of course, whatever the values are there, that values I will get display. First let me comment all this, run the code. So whatever the value I have given, ff1 good packet, ff1 good packet, all this I have got it. Okay, next what I'll do is I am going to do the I'm going to implement the class assignment, which means what? Packet 1 is already object is available. Okay, that packet 1 object I'm assigning to the packet 2, which means what? Packet 1, packet 2, both are pointing to the same container, both are pointing to the same memory. Okay, now packet 2, if I display, what output I will get? Same output only I will get. What output I got for packet 1, same output I will get for packet 2 also, because both are pointing to the same memory. Okay, so if I display packet 2, run the code, I will get the same output. Okay, see, ff1 good packet, ff1 good packet. Okay, same output I am getting because both are pointing to same memory. Now see, both are pointing to same memory. Okay, which means what? If I write the diagram, if I write the diagram, so one memory is there, packet 1, packet 2, packet 1 and packet 2 both are pointing to the same memory. Okay, so what is that address value ff some, what is that packet type? One second, what is that values that is given there? Data write packet type. Okay, so here data write packet type. Initially what are the values that I am giving for that? I am giving ff1 good packet. Okay, ff1 good packet. Okay, now packet 1 I displayed, I got this output because packet 1 is pointing to this. Okay, packet 2 also I'm displaying, I'm getting the same output. Okay, now packet 2 dot data. So with the help of packet 2 I am trying to change the value of data. Okay, what I'm doing, ab I'm doing, remove this and write ab. Okay, next using packet 2 I'm changing the this one also, I am writing bad packet. Okay, see, when I do like this using packet 2 I am making the changes in the memory. Is it reflecting in packet 1? Yes, because packet 1 is also pointing to same memory, packet 2 also is pointing to same memory, so both are pointing to similar memory, means no matter you do the changes using packet 1 or you do the changes using packet 2, that is not a problem, it will end of the day it will reflect in the same memory. So after that if you display packet 1, what output you will get? AB1, what is this? Bad packet. This answers only you will get here. Correct? That is what I am trying to verify here. So I'll uncomment this. Okay, actually I have done the changes using packet 2 and I'm displaying the packet 1 to check whether the reflection is visible in the packet 1, yes or no. Okay, see, I'm actually displaying packet 1. Okay, I'm getting the same thing, AB1 bad packet. Okay, but I actually done the changes using packet 2. Okay, you do the changes using packet 2 or you do the changes using packet 1, that doesn't matter. End of the day you print packet 1, this answers only you will get, you print packet 2, this answers only you will get, because both the handles are pointing to a similar memory. Okay, so till now is it clear? Shallow copy answer. Others? Because you are not understanding.
No, no, ma'am, I am understanding. I have just a confusion, ma'am. In this, memory is just sharing or what is just copying in one another.
It's not copying. Still, I'm not copying. No, I'm just assigning. Assigning in the sense I'm just trying to point the handle to one particular memory. Actually, basically, I have created a memory for P1 initially here. Packet 1 equal to new, which means what? For packet 1, I had created a memory. For the same memory, I have created another pointer, that is P2. That is what exactly I'm doing in the assignment. Whatever it was there in P1, that I have allotted to P2. P2, P1, both are pointing to the same memory.
Okay, ma'am.
So everyone have to respond here. Okay, yes, again and again I'll not tell, it's mandatory to respond over here, and today I'll upload the recordings. Okay, so 13th, right? Lavanya, yes. Aishwarya, Sudha is on leave. Sai Krishna, yes. Sheetal is absent. See, if you remain absent without informing me, the recordings won't be allotted. Okay, so if you want the recordings, at least you have to inform me that you will watch the recording, or else you have to take a leave. If you are a live session candidate, at least you have to take a leave. Okay, Ganeshwar is present. Gopi, yes. Sudha is absent. 7, right? 1 second. No, another one. Okay. Okay, so that's about the class assignment. Okay, so both the handles are pointing to a similar memory. Now in the shallow copy, what happens? That is actually the disadvantage, correct? So that disadvantage will be removed with the help of the new constructor. Okay, so we are writing class and class. Okay, some here nested class I've taken. Okay, before nested class, let me explain the main class. Okay, so in the main class, again the same code, address, data I have taken, two properties I have taken. Okay, now I have written another class and class, and this I consider as a nested class. Why? Because this definition I am calling here. Okay, so this class and class, whatever this definition is there na, that particular definition I am calling over here. I mean to tell, in another class I am calling the handle, or I'm declaring the handle of another class. So this becomes so this is usually the nested class, so this becomes a nested class. Okay, now what I'm trying to do, for address and for data, this is a property of my own class, main class. Okay, I have given the value as 10 and ff. Okay, next, for this ar, for this class I'm creating an object here. Okay, that is done. Now I'm trying to print address, data. Okay, this will be printed, not a problem, but I'm also trying to print ar dot starting address. Ar is a name of a nested class. Inside the ar, do I have starting address? Yes. Do I have ending address? Yes. So that also I'm trying to print here. Where I'm trying to print, inside the main class I am trying to print what is present in the nested class. Okay, inside the main class properties also I'm trying to print, nested class properties also I am trying to print, both I'm trying to print. Okay, now what happens, so as I told, this time I'm using a new keyword. Okay, so packet 1 I'm creating an object. Okay, but this time packet 1 object is allotted or is copied into a new memory of p2. Now p2 is having separate memory, p1 is having separate memory. Okay, now using p2, if you do the changes, okay, till here I will tell. Remaining, yes, so using p2, if you do the changes, the changes won't get reflected in p1. Why? Because p1 is having separate memory, p2 is having separate memory. Okay, so let me run the code. I still didn't explain about nested class. Okay, nested class, keep it aside. First, let us understand about this. See, so 10 FF 10. Okay, first two displays I'm getting. So I'm doing the changes using the packet 2. Okay, so let me display packet 2. Let me display packet 1. Okay, yes. Now whatever the changes I have done using packet 2, that is reflected only in packet 2. It will not get reflected in packet 1. Okay, yes. See here, that is 68, whatever the changes I did, that is reflecting only in packet 2. See, it is not reflecting in packet 1 because both are having separate memory this time. Unlike in last code, both the pointers were pointing to the same memory, but this time both the pointers are pointing to different memory. So using P2, whatever the changes you make, that is reflected only in this memory, this container. Using P1, whatever changes you make, that is reflected only here. See, for example, now using P1, I will change some value. Using P1, I will change the address as 52, 58. Okay, only in P1 memory it is reflecting. Okay, it will not reflect in P2's memory. See, 58 I'm getting only in packet 1. I'm not getting that in packet 2. Okay, because both are having independent memory this time. Okay, now what about the nested class properties? So using packet 2, if you do the changes also, using packet 1, if you do the changes also, the changes is again reflecting in both the memory. Again the same problem. Okay, see, let me just do one thing. Using packet 2, I am changing the starting address. Using packet 1, I am changing the ending address. Okay, see, for the main class properties, I'm having different memory. That is not a problem. But I'm using nested class. No, see, starting address is about the nested class. Okay, for the nested class, again I am having a same problem. Okay, see, after making the changes for the nested class properties, I am trying to print packet 1 and packet 2. Okay, let me check the code. So the changes will happen in both the output, packet 1 and packet 2 output. See, 6080. Okay, it is reflecting in both of the output. In the packet 1 display also it is reflecting, in the packet 2 display also it is reflecting. Again the same problem. Okay, means in diagram way, if you want to write, it will look something like this. So this is my nested class. Okay, so this is my main class. In the main class I have resolved the problem. Okay, so I have written, what is the syntax that I have written? New of P1. By writing like this, what I have done is P1 is pointing to some different memory, P2 is pointing to some different memory. This problem is resolved now. But in the nested class, again P1 is pointing to the same memory, P2 is also pointing to same memory. So again the same class assignment disadvantages come into picture. If you use nested class in shallow copy, then only this problem will arise. If you are not using nested class in the shallow copy, this disadvantage will not be there. Okay, yes. Yashwant is asking something. Sometimes your voice is breaking. Is it breaking, guys? I think my network is stable. Others, please respond. Is my voice breaking? Okay, so Yashwant, there might be some problem in your network. Anyways, I will provide the recording. Once again, you can watch if required. Okay, yes, 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 Sajna. Yes.
Now whenever
Mm,
we are coding, we are
mm.
not using shallow copy or class assignment, right? The main concentration is on only deep
Deep
copy,
copy,
right?
exactly. Application wise, we always go for deep copy because anyways we are having class assignment shallow copy as a disadvantage only. Okay, so but
Okay.
deep copy will come into picture when you are using nested class. Just imagine in your client project you do not have nested class, then why you will go for deep copy? Simply you go for nested class. That is enough.
Okay.
Because
Okay. So this
if you
is
uh,
used when we are copying something, like basically some router project or something. We have to copy the data and pass on to something while during
hmm,
that time we are using this, right?
exactly. Only when you want to copy, then only this class assignment, shallow copy and deep copy will come into picture. And class assignment is anyways we are not using because there 100% the problem will arise. You have to either choose shallow copy or deep copy. And here also, if you are using nested class, go for deep copy. If you are not using nested class, then go for shallow copy. That's it.
Okay. Okay. Thank you.
Yes. Okay, so that's about the shallow copy. Is shallow copy clear for everyone? Only when you are using nested class, the same disadvantage will again arise. Someone raised the hand, I think. Yes.
So no
Yes.
application of class assignment, right? We
No,
are
no,
not
no, no,
using
no.
it anywhere.
No, no. We are not using application wise. We are not using class assignment. Class assignment we were using in Verilog. Okay, in the Verilog we used to use class assignment. Here in SV we are not using it. Yeah. Okay, now coming to the code of deep copy. Deep copy in the nested class also separate memory we have. In the main class also separate memory we will be having. Okay, but for that we have to little bit write extra lines. That is, we have to write copy method. Okay, how to write that? This is 100% interview question. They will ask you to write the code. Okay, interviewer will ask you to write the code, so please concentrate here. Okay, so now I told there is no problem with main class. Okay, in the main class whatever the disadvantage was present, I removed the disadvantage in the shallow copy itself. Okay, now there is no problem with main class, so you no need to worry below. Now the problem is in the nested class. So if you people are using nested class, make sure to write one extra method, that is copy method. So what exactly you are going to do in the copy method means, I just told that in the diagram wise, if you see, okay, here only I have written, no, 1 second. Here, see, the nested class is having only one memory, correct? No, so what I can do for this, how can I remove this disadvantage? My intention is for the nested class I should be having two memory, so that one pointer will point to one memory, another pointer will point to another memory, correct? No, by writing this syntax p2 equal to new of p1, I was successful in creating one memory, but I was unsuccessful in creating a one more memory, correct? No, so to create this memory I have to write a copy method, and for the copy method itself I am creating a memory, which means what, in the nested class now I am having my own memory. Okay, in the shallow copy, if you people have observed, I have written one object. 1 minute, this is class assignment. In the shallow copy, where is that? This is shallow copy, so this is a nested class, correct? No, this is nested class. This nested class object I am creating here, correct? No, one memory only created. One more memory who will create? Myself I have to create here. Nested class itself, it has to create one box here. Okay, one box already created here. Okay, that is why I told it is a disadvantage, means only one memory is created for this. No, for this class only one memory I have created, so two handles you have, so two handles also will point to a same memory. But now here there was no object created, correct? Now it's my responsibility that I have to create another object here. How to create? Via copy method. Means what I'm trying to do is, in the shallow copy, this is my nested class. In the nested class there was no object, there was no memory. Okay, in the main class what I did, in the main class I created an object for the nested class. Okay, this nested class memory is present here. So here pointer 1, pointer 2 both were pointing to the same memory. But now in the deep copy my intention is, for the nested class also I want to create one container. In the main class anyways I will create a container. So how many containers have become? 1 and 2. Now the two objects will be there for the same nested class. So here one pointer will point to one memory, another pointer will point to another memory. My problem resolved. Okay, but for that in the nested class I am going to create one copy method. For that copy method itself I will create a constructor, I will create an object. That object I will call here. This is very important. It's not like you are creating an object and you are keeping it outside the class. No, actually you are doing the deep copy or shallow copy inside the main class. This is your main class, correct? You should see to that. Okay, you are creating an object outside the main class. You create it. Once you create, call that method inside also, then only that will come and occupy its memory here. And now p1 will be pointing to one memory, p2 will be pointing to another memory. That's what exactly we are doing it here. Okay, I repeat again, in the deep copy, this is my nested class. This is my main class. In the shallow copy, what did I do? In the nested class object I created here, that is anyways there, I have to create it. Okay, you might have seen ar equal to new, I have written here in the shallow copy. Okay, so this is one memory. Okay, so as I was having one memory in the shallow copy, p1 and p2 both pointed to the same memory. Okay, now in the deep copy my agenda is I want to create another memory for the nested class. Okay, so where do I create? Inside the main class can I create? No. If I create like that, again there will be multiple memories and there is a confusion. So what I'm trying to do is, in the nested class itself I'll create one memory using the copy method. Okay, that memory I will create here. The creation will happen outside the main class only, but after creating a memory, this particular memory I will call it inside the main class and I will keep that here. So now inside the main class I am having two memory for the nested class also. Not only for the main class, for the nested class also I will be having two different memories. Now pointer 1 will be pointing to one memory, pointer 2 will be pointing to another memory. That's it. Okay, so now with respect to code, how I am achieving that. So as I told, I want to create this box, this container outside the main class, correct? No, that is what I'm trying to do here. See, in the nested class only I have created function in function, I have written the name of the function followed by the copy method, as I told. Okay, because I want to call it inside. No, that is why wantedly I'm writing this. And here I have created an object. So now see the diagram. That's what I have created an object. Okay, once I create an object, what I'm trying to do, this property is there. No, this property I am assigning to the copies start address. Means in the copy method already I am having starting address and ending address. Here exactly my intention is, I have created a bag. I'm packing a luggage. I need to go out of station. I'm packing a luggage. In this luggage, I'm keeping everything whatever is there in my home. Okay, my intention is the starting address and ending address whatever is present in nested class, I am copying that exactly in this luggage, so that when I go out of station, wherever I go in my destination, this starting address and ending address also I have to take and go here. Okay, so see, that's what I'm trying to do. This means what? This refers to class property, correct? That class property I am assigning to copy method's starting address. See, this function is written inside this class, means this function by default it contains starting address, ending address. Okay, means here in the argument it is not written, but it is understood that starting address, ending address is anyways present in this function. Okay, so this property is assigned to the argument of the copy method. Okay, so that when I call this copy method here, I'll call it. Okay, when I call that copy method in the below main class, so these starting address, ending address also will go along with that. Okay, yes, and I'm returning the copy method. Okay, so this is extra lines that you are supposed to write to create one object in the nested class. Now what I am doing, as usual, create a handle, create an object. This was already created in shallow copy also. Okay, now here again one more copy method I'm writing. Okay, here this is a copy method of the main class. So in this main class again I'm creating one object. Okay, this time what I'm doing, this dot address, this dot data, this one, these two again I am assigning to the copy method. Means in the copy container I am dumping address, data and starting address, ending address, all the four variables. Okay, and this is very important. If you comment this, again everything goes wrong. Okay, here what I'm trying to do, ar dot copy, in the ar, in the address range whatever the copy method is there, that I am assigning to copy dot ar. Copy method is where it is there, copy method is present in main class. Inside the copy method I'm having the ar na, for that I am assigning. Here understand this line, let me copy this here. Here, 1 minute, this is the container that I created. In this everything is there, starting address, ending address, everything I copied and I'm ready now. In the main class also I am creating one copy method. Okay na, this copy method is also having an object. If you observe here, see, this main class copy method is also having the object. Okay, this is also having the object. Now what I'm trying to do, observe that line, er dot copy is equal to, class assignment I'm doing, is equal to copy dot ar. what I'm trying to do, inside this container I am keeping this container nested class. What is this? Memory. Nested class memory. This is how I'm keeping. This is the meaning of ar dot copy is assigned to copy method of my main class dot ar. The meaning of this line is this diagram. Inside the main class copy method, I am keeping the nested class copy method. Okay, which means what? Simply I can't create and I can't command occupy here. Okay, because it is nested class. Some other person is coming to our home means we are having some specific space for them. It's not like everywhere we can't give them the access right now. So I am creating one particular copy method memory in the main class. Inside that copy method of the main class, I am keeping the memory of my nested class. Okay, and anyways I'm having one memory. This is anyways there. Where is that? uh, this one. This is anyways there, that you do not have to worry. This is constant. In shallow copy I also had this memory. Now also I'm having this memory, but now what I'm trying to do is this extra memory I am keeping that inside the copy method of the main class. So this is my second memory. Okay, now when you do the same syntax, like when you write the same syntax, but this time I'm using copy method. Okay, p2 equal to p1 dot copy. You can write like this, or you can also write like, 1 minute. This is one way of writing the syntax. Another way of writing the syntax is copy of pkt1. This is also fine. Okay, both the syntax are okay. Any one syntax you can write it. Okay, but this time I'm not using new constructor, because new constructor problem already I resolved in shallow copy. This time I will call the copy method. When I call the copy method, how many memory are there? Two memory is present. One is main class memory. Inside the main class memory, nested class memory I have called. Okay, so that is why I'm using this syntax. With the help of this syntax, now nested class are having separate memory, main class is having separate memory. Okay, so if I run the code, I'll analyze what all values I have written here. New. Okay, p2 dot address. I made somewhere there is some mistake. I'll write down that values. Okay, so now let me analyze what all values I have given here. Let me just write the diagram for that. It's not complicated. Only thing is little bit the code you have to understand how to write the code in the deep copy. That is why in the definitely in the shall interview deep copy only they will ask. Okay, see, packet one memory is created. I'm speaking about the main class. Okay, for that what is getting pointed? Packet 1 is getting pointed. Okay, packet 1 I'm displaying. Okay, packet 2 another memory I'm creating. Okay, all this is in the main class. Okay, na nested class is still here. This is okay. Packet 1 I will display. Okay, another memory, packet 2 I will display. Now using the syntax of copy method, I am executing the syntax. Okay, then what I'll do, when I execute the syntax, what happens? Already copy method is present here. Okay, here copy method was already present. Okay, inside this copy method another nested class copy method is called. Okay, what is these two? These two is exactly belonging to my 1 minute. 1 second. This is okay, and here this memory I had created, na copy methods memory, right? I have created here, but I called that here. How did I call? I already have a copy method of a main class. Inside that copy method, this one I called here like this. Okay, now this is one memory. Okay, maybe that is pointing to p2. Just imagine. Okay, now here nothing is there. Okay, next one more object is created for nested class. Which one you tell me? In the line number, this one. Okay, line number 31, whatever er equal to new I have created, that is anyways present here. that is n was present here. See, this is main class only. Okay, this is nested class AR equal to new. The moment you write this memory had already created in shallow copy also. Now what extra I am doing? I have created a copy method. In that copy method is again called. Okay, so now how many memories I am having for nested class? 2 memory. Okay, so this memory and this memory is belonging to nested class. This memory and this memory is belonging to main class. Means inside main class I am having totally 4 memories now. Not 2 memory, 4 memories. In the shallow copy, how many memories I had? 3 memory. 3 memories I had in the shallow copy. Okay, 2 memory for main class, 1 memory for nested class. In the deep copy, totally I am having 4 memories. Okay, now p2 dot address is something that is belonging to here. Okay, address equal to what? 68. Okay, see, everywhere I'm having address. What was the variable? Address data, starting address, ending address. Okay, address data, starting address, ending address. Here I'm having starting address, ending address. Here I'm having starting address, ending address. Okay, na p2 dot address equal to 68. That 68 is reflected here. p2 dot ar dot starting address. p2 dot ar is here. Okay, so 1 minute. This is main class, packet 1. Like this I'll write, it will be clear. Packet 2. Okay, so what is this? Address and data, starting address, ending address. Okay, address and data, starting address, ending address. This would be better. Okay, next what I'm doing, okay, 68 I am updating here. Okay, p2 dot ar dot starting address. P2 inside that ar, this one is ar. Okay, this is ar. Okay, ar dot starting address is 60. It is reflecting here. Okay, p2 dot ar dot ending address is 80. p2 dot ar dot ending address is 80. Okay, and then I'm trying to display both the packets. Okay, now what do I have to observe? Inside the packet 2 only these reflections are happening. It is not disturbing the packet 2 packet 1 data. Okay, so what are the default values? That also I will check. Wait a minute. The default values was 10ff 1050. Okay, 10ff 1050. This is 10ff, this is 1050. This ff is this is the output that I'm supposed to get. It means everyone is having separate memory here. Okay, now let me check my output. So first 10ff 1050 was common, correct? No, here 10ff 1050 10ff 1050 was present. Okay, before doing the deep copy. After doing the deep copy and after doing the changes, see, in the first column what should I have? 10ff 1050 10ff 1050. Okay, in the second box what should I have? 68ff 6080 68ff 6080. See, if you draw the diagram, it is dead easy for you to understand. Okay, so deep copy diagram will look something like this. Okay, the same thing shallow copy, how it was looking. This is my main class, means packet 1 was pointing here, packet 2 was pointing. Nested class was having only one memory, for which packet 1 packet 2 both was pointing. This is the diagram. Okay, this is a shallow copy diagram. This is the deep copy diagram. Okay, diagram, at least if you properly understand, definitely whatever the question they give in the interview, you will be able to solve this. Okay, so diagram you have to properly understand. Okay, and main importantly, deep copy method, how to write the copy method in the nested class and how to write the copy method in the main class. That part only definitely they will ask you in the interview. Okay, so if they ask you people to write the code, they will ask you to write the code for the deep copy especially. Okay, yes. So is it clear with respect to the deep copy? Yes. Is deep copy clear? Diagram is very important. I'm repeatedly telling. Okay, invest more time in understanding deep copy. 100% question it is. No matter you use it for service company, product company, whatever the company it is, 100% deep copy question they will ask. And one more scenario is recent interview. They have given the code for the student. Same deep copy code only they have given. They have asked the output. And what the student has done, simply he has written this diagram. He didn't do anything, simply has written this diagram. Just now how I have written the value, the same way he has written the value, he told the output. Simple thing. Okay, nothing to get confused here. Diagram is 100% important. They are giving the code for you people. You have to just enter that values here. Okay, you can understand this. Now p2.ar, p2.ar, inside that 60. Okay, substitute that values here and tell him the output. Okay, so if you don't know this diagram, then predicting the output will become so difficult. But if you draw this diagram, it is dead easy. Okay, yes. So that's it from my end for today. Okay, so randomization I'll start from tomorrow. Okay, tomorrow also we'll have some doubt clarification session first, and then we'll go to the main session. Okay, and I will upload the recordings. Okay, that's why I'm not continuing with randomization, because many of the students have not watched the past 3 sessions. I will upload that, and tomorrow I will start with randomization. Tomorrow some lengthy hour we will have, 1.5 hour session we'll have, where I'm going to explain about the randomization, because randomization is little bit lengthy topic. Okay, and after that constraints document also I will provide for you people, that you have to practice. Okay, constraints is 100% important. I have solved a paper, okay, of constraints, whatever is asked in interview. That set I'm having, that set I'll be allotting for you people in the Google Classroom. Okay, yes. Okay guys, so as I told, till 17th there is no review. After 17th only I will start taking the reviews. Okay, for that I have to complete the randomization. Once I complete randomization, I will be free. Then we can slowly incline towards the Mux project, and at that point of time I will start taking the reviews. Okay, yes. Okay guys, so thank you. We'll continue tomorrow. Okay, thank you guys.